Alrighty, everybody. I just got the okay to start our planetarium show, so I'm gonna put away our space trivia questions because now we're gonna be heading into the unknown. Ooh. And once again, welcome everybody to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? Hee hee hee. Don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be. I just want to let you know that I'm here. I'm going to be your space pilot in a sense, and everything that you see in purple is going to be one enormous screen, thanks to the help of 6 different projectors hiding throughout our planetarium. So if you're looking for those projectors, we got 2 at the very bottom, 2 in the middle, and 2 at the very top of the planetarium dome, just below the purple glow. And just to let you know, folks, everything that you're going to see on this big screen is backed by scientific data, evidence, peer review, critique. And we also like to use some pretty cool science visualization software to give you this very immersive experience. And to tell you folks, the show that we're going to be doing right now is different from all the other previous shows that we've done here in the Morrison Planetarium today. This show is called Tour of the Universe, and it's my absolute favorite to do because this show is completely live. I'm going to be talking for the next 30 minutes. And what we're going to be doing is that we're going to be starting off pretty close to Earth, and we're going to be zooming all the way out to the very edge of the observable universe. Hopefully, by the end of the show, you won't have an existential crisis of where we are in space. But just to let you know, we are very small in the grand scheme of things. So just want to pre warn you. And before we get started with our show, folks, I do need to go over some quick house rules just so that we're all on the same page. We're going to have a great experience in the planetarium. There's quite a few of us in here right now. First off, there's no food or drinks allowed in. If you manage to bring any snacks or beverages, make sure those are put away till the end of the show. We want to keep the theater nice and clean for all the guests coming in the future, so we do appreciate your help in keeping this theater clean. Also, if you happen to have any 21st century gadgets like cell phones, smartwatches, tablets, anything that produces bright white light or loud sound, now is the perfect time to turn them off, deactivate them, put them away for the next 30 minutes, as these can be pretty distracting in our planetarium. This room's going to get quite dark, and having a really bright white light in a dark room is not only distracting for you, but for the folks sitting behind you. So we want to be courteous to everyone in the planetarium dome. And also, folks, just to let you know, there is, looks like about 100 people in the planetarium dome right now. So we're going to be here for the next 30 minutes. We do highly encourage wearing a mask while we're in here, but that's your choice. Just want to let you know, there is about 100 people in here. So we're going to be here for 30 minutes. And also, folks, if you do need to exit the planetarium for any reason, you're more than welcome to do so. All we ask is that you exit at the very top of the planetarium. That's where the exits are going to be before, during, and after the show. So when in doubt, always make your way up the stairs, not down them. Although, if you do, if you're a person that has trouble climbing the stairs, don't worry. Totally understandable. The stairs are very steep. Just remain seated. Once the show's over, we'll have a staff member escort you to a lower exit. So just stay seated once the show's over. And last but not least, folks, this show is very immersive thanks to our 70-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, you don't like flying through space, there's a really quick and easy way to ground yourself. All you got to do is close your eyes, take a few big deep breaths, and your brain will remember that you're sitting in a planetarium in San Francisco in Golden Gate Park and not flying through space. Not more than the usual, at least. But with that being said, it looks like we're ready to go. Y'all ready for a show? Alrighty, everybody. I invite you to sit back, relax, and here comes Tour of the Universe. Alrighty, so as I mentioned, we're gonna be starting off pretty close to Earth, but this doesn't really look like the Earth. We can see the Earth just down below us. We can actually see the city lights of India popping up. Looks like we're just off the coast of India right now. So we can see all those city lights popping up, but we're gonna be starting off a little bit above our planet Earth at this really cool thing called the International Space Station, or we also like to shorten it as the ISS. And a lot of people tend to ask me, hey, Christian, what's the International Space Station? I always hear about it in news articles on the news, but I don't even know what it is. Can you explain it for me? Well, don't worry, folks. The International Space Station is pretty much a big laboratory, a research facility that's orbiting around our planet Earth. And how this came to be, pretty much a lot of countries, a lot of nations across planet Earth came together, and they wanted to figure out what happens to things in space. So they all got together and created this really cool thing. And up here, they can test out some really different things that they wouldn't be able to test while they're on planet Earth. Some of the experiments that they'll conduct up here are things like what happens when you try to grow plants in space. Do the plants grow differently with less gravity? Another one is what happens when you spark fire in space? Does the flame act the same? Does that act differently? And one of my favorite experiments is where they had two identical twins. One twin lived on Earth for about a year, the other one lived on the International Space Station for a year. After that year, they compare and contrasted. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of body mass index, a lot of muscle, pretty much because you don't have gravity constantly working down on your muscles at all times. So if you're planning to, say, live in space for a long period of time, make sure to exercise daily. And folks, the International Space Station right here on our screen looks enormous, but it's not that big in actuality. It's only about the size of an American football field. So if you've never been to an American football game, don't worry. You can also use the entire California Academy of Sciences, the museum that we're sitting in right now. That's how big it is. And also, what's really cool is that the International Space Station is going really, really fast. It's going a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And right now, also, it looks like we're really far away above our planet Earth, but the International Space Station isn't too far away either. It's only about 225 miles above the surface of our planet. So 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. And to tell you the truth, folks, this is as far as we put humans out into space nowadays, only 225 miles above the surface of our world. Because traveling out into space is very, very expensive. First, you got to get yourself a rocket ship, then you have to build a rocket ship yourself, and then you have to account for all the rocket fuel. And I mean a lot of rocket fuel. And once you get your hands on all that rocket fuel, you have to account for all the food, water, all the air you're going to be breathing while you're up here in space. So the bill starts to get quite costly quite rapidly. But, folks, the International Space Station is just the first stop on our tour of the universe. Just want to make sure that we get a sense of close to home. But let's slowly fade away from our International Space Station. And now we're going to slowly lose it compared to our planet. And before we lose track of the International Space Station, I want to add a nice little orbital path so we can keep track of it. There we go. And let's zoom on out. And now, folks, we are looking down at our planet Earth. And to let you know, the space program that I'm using here is something you can go home and download if you like. The space program that I'm using right now is something called OpenSpace. So if you go to your favorite search engine and type in OpenSpace Project, then you'll find where you can download this software. It's really fun. But just to let you know, this program isn't entirely finished. It's in its beta phase. So we may come across a few bugs and glitches. If we do, I'll point them out. Hopefully, we can look past them. And also to tell you folks, this program uses a lot of processing power. So if you have an older computer, I wouldn't recommend downloading it. It may overwhelm your computer. But if you have a newer one or a gaming computer, give it a try. It's a whole lot of fun. So the space program is called OpenSpace. And if you're a person like me that doesn't want to download things because downloading, I never have enough memory on my computer. Well, we have another great alternative called NASA's Eyes. So if you go to NASA's Eyes, type it in your favorite search engine, kind of like the human eyeball. You don't have to download anything. You can also fly through space just like how I am. So two great alternatives. We have OpenSpace and NASA's Eyes. So a lot of fun. But folks, let's leave our planet Earth because now we're going to be making our way over to our nearest natural neighbor to us in space, the moon. Now, we humans have been to the moon before, but that was quite a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun as well. They got to play golf up here. But again, folks, last time we sent humans to the moon was 1972. That's a little more than 50 years ago or so. But don't worry, NASA has a new space mission in the works that's going to be sending humans to the moon once again. This new space mission is called Artemis. And pretty much NASA's goal with Artemis, they want to send humans to Mars. But before we send humans deep into our solar system, we got to figure out exactly how we're going to live out here in space. So the moon is a perfect stepping stone to figure out all the logistics. And what's also really cool about Artemis is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout the moon. Pretty much our technology in the past 50 years has improved greatly, and we're able to conduct science that we weren't able to do 50 years ago. So maybe we want to set up a lunar base here at Copernicus crater. Maybe that's a point of interest. One place that we definitely want to set up a base is in the south pole of the moon. That's one of the location of one of the largest impact sites in the solar system. So that is one place scientists definitely want to go take a look at. Or maybe we also want to go take a look at some collapsed lava tubes and get some new information from there. And so maybe they'll set up a lunar base there. Maybe they'll set up a lunar base on the right side over here. But what's also really cool is that they're going to have a space station that's going to be orbiting around the moon at all times, kind of like with the International Space Station that we just saw. So if anything was to go wrong for these astronauts while they're on the surface of the moon, they can launch off the surface and head to that space station where they would be safe. So look out for any news about Artemis in the coming years. We humans should be heading back to the moon relatively soon. And folks, when we look at the moon here up on Earth, sometimes the moon feels really, really close to us, especially when the moon's really close to the horizon. But the moon is really far away from us. It's roughly about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon. If you drove for 4 months nonstop, going about 80 miles per hour, although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using using inches to describe the distances between cities because space is so large. So astronomers instead use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye bye, moon. We'll see you later. And on our journey, folks, we're going to be heading out or stepping out into a much larger realm of our solar system because now we're going to watch the moon and the Earth as they slowly disappear. In fact, before we lose sight of the moon and our Earth, I want to add some planet trails so we can keep track of stuff out here in space. There we go. And on our journey as well, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models showing us the most accurate information and images available to us. So thanks to that program, OpenSpace. So big shout out to OpenSpace. Love them. But we're zooming so far out now that the nearest star to us, the sun, should be coming into view. And here comes the sun. Do 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 do. And folks, the sun is really, really far away from us as well. The sun's roughly about 93 million miles away from the Earth. Whew, 93 million miles away. That is a good distance. But in terms of speed of light, that's not far at all. So again, we're the third rock from the sun. That's us right there. One, two, three. One, two, three. And between us is 93 million miles away from us and the sun. And it only takes light at the speed of light 8.5 minutes to cross that really large distance. So 8.5 minutes, that's not that bad. Now, that's a really cool concept to keep in mind because let's say the sun was to turn off all of a sudden, there was no more sunlight being emitted. That last bit of sunlight would be travel that 93 million miles, that 8.5 minutes at the speed of light. And then finally, that last bit of sunlight would reach us here on Earth, and then the daytime would become nighttime. And this also works for really far away objects in space because let's say we're looking at a star like this one over here that's 70 light years away from us. Well, we're looking at that star as it looked like 70 years ago because that light that just reached us traveled 70 years to get to us. So when we look at really far away objects in space, it's kind of like looking back in time in a sense, which is pretty cool and also really weird. But now that we have a nice bird's eye perspective of our solar system, let's get a refresher of what's inside of it. There's lots of cool things in our solar system. So right in the middle, we have our star, the sun. The closest planet to the sun, we've got Mercury. Then we have Venus, Earth, that's us, and then Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it will look like for to highlight all those asteroids in the asteroid belt. Give it a bit, there's quite a few of them. And contrary to popular belief and also Hollywood films, if you actually send your spacecraft through the asteroid belt, there's about a 1 in billion chance of your spacecraft getting hit by an asteroid. The reason why is because there's so much space out here between all these rocks. So it's not like in the movies where you have to dodge and weave, unfortunately. But it makes for a good movie. And then past the main asteroid belt, we have the really big planets, our gas giants. We've got Jupiter, and then we have Saturn, the Jovians. And then past them, we have our icy gas giants. We have Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto at the very top of the screen right there. And a lot of people tend to ask me, hey, Christian, why did Pluto get kicked out of the Planet Club? I learned about it, and as I was growing up, I still think of Pluto as a planet. Oh, I love that place. I love Pluto. Viva la Pluto. Well, you see, folks, we got really good about learning about the outer part of our solar system, specifically the region past the orbit of Neptune, what we like to call the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, the Kuiper Belt's going to be all this stuff. Whoa. Yeah, so there's a lot of stuff out here in the outer part of our solar system. And you can kind of think of it as like a second asteroid belt. Mostly what you're going to find out here are icy asteroids and short period comets, comets that don't stray too far away from the sun. They have a nice, quick little short orbital path. So short period comets. But in 2006, astronomers found a whole lot of objects, more than 400 objects out here in this Kuiper Belt region. And they couldn't call all this stuff planets. Some of the stuff was bigger than Pluto. So all the astronomers in planet Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And one of the criteria is that you need to be so big and so massive that you push all the other stuff out of your way. Unfortunately for Pluto, it kind of dances around its moon Charon and also gets pushed around by other objects. So that's why Pluto got kicked out of the Planet Club and is now considered a dwarf planet. But don't worry, there's quite a few dwarf planets out here. We've got Make, Haumea, and Aries. And of course, closer to home in the main asteroid belt, we have Ceres. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be adding on screen, folks, some of the many different spacecrafts we sent out in the 1970s to explore our solar system. So now we have the trajectories on screen from Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see this interaction right over here in the bottom left. And thanks to that flyby, we were able to get some amazing high-definition images of Pluto thanks to that flyby. And all of these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not yet traveled as far as light travels in a single day. In order for sunlight to reach all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light to get this far. So only 5 hours. Not too bad. But folks, let's leave our planetary scale behind because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us over 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And let me just make sure I've got the right star system. Looks like our program is stuttering just a little bit, but hopefully we can look past that. There we go. So Alpha Centauri is going to be this far right one right here. And then our star system is right in the middle of our screen. And 4 years between us to get to the next star system. Now, 4 years at the speed of light really doesn't put into perspective of how long it would take us to get there. Well, if you were to get in a rocket ship today, left our planet Earth, and made your way over to the next star system, it's going to take you about 8,500 years just to make that journey. Whew, and that's just a one-way trip. So that's a very, very long road trip. But folks, let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. So again, we are now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years, emitting in all directions out from the Earth. And this first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year. So is anybody out there listening? And folks, right now I'm going to be adding on screen some many markers. These markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planet orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found 5,000 exoplanets confirmed, and just in the nearby vicinity to us. So 5,000 other planets close to us. Whew, that's a lot of planets. And that 5,000 number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. So they're constantly scanning the night sky. Now, to figure out if any of them are Earth like with conditions suitable for life as we know it, well, we can't answer that question quite yet. Pretty much new space telescopes are being created right now. So we just have to wait for those space telescopes to be made. And once that happens, maybe we can answer that question. So I'll give it a few years or so. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system all the way on the left side of our radiosphere. Let's say this one over here. We find an alien civilization all the way on the other side, let's say 60 light years away from us. We shoot them a text message. We say, hey, we live over here. Take 60 years to get to them. They listen in, answer back, another 60 years to get that response. That is a 120-year conversation in the making. Whew. And I can barely wait for a text message from my friend. Hee hee hee. But of course, folks, planetary systems beyond our radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And I want to put away our exoplanet markers, and I want to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way Galaxy. So keep your eye on that radiosphere. Alrighty, folks, we are now looking down our Milky Way Galaxy, and can anybody see their house from here? Just kidding. And to tell you folks, our Milky Way Galaxy is incredibly large. If you wanted to cross our Milky Way Galaxy from one side to the other, it's going to take you about 130,000 years to cross that distance. So that's how large it is. But not only that, our Milky Way Galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If a recent discovery of so many exoplanets within our small neighborhood, within this vast star city, is any indication, there could be billions of planets and potentially millions of Earth like planets throughout our single galaxy. And before we leave our Milky Way Galaxy, I do want to show you it from a sideways perspective. When you look up in the night sky and a friend always says, oh, look, there's the Milky Way Galaxy. You can see it right there. And you're like wondering, what's the Milky Way Galaxy? I don't know what that is. Well, they're pointing out the galaxy plane of our Milky Way. So this is what you're seeing up in the night sky. And this is where you're going to find all those stars, gas, debris, planets, and stuff. So everything right here in our Milky Way is in that plane, or what you'll see up in the night sky. Now, this is important because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south instead of looking through that plane of the Milky Way, which has, again, those planets, stars, gas, nebula, things that block their view of the universe. So again, we like to point our telescopes galactically north and galactically south. That's going to come important later on in the show, so just keep that in mind. But let's leave our Milky Way Galaxy, folks, because the Milky Way is only one of hundreds of billions of galaxies that comprise the known universe. So in this giant leap, we're now going to see a view where each point of light no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group, which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue zooming out, folks, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters. We can see a cluster on the right side over here. We can see another cluster over there. And they like to not form clusters. They like to be spread out where there's very few galaxies or voids. So we can see some voids over here in the middle of our screen. On the very top left of our screen, we don't really see any galaxies in that direction. So you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And also, folks, we've zoomed so far back now that the picture that we're looking at represents the closest 30,000 galaxies to us in space, over 300 million light years across. And we now have automated systems that are even mapping the most distant galaxies. So now we're going to see the large scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Whew, I feel small. And not only that, our universe is not shaped like a bow tie or a butterfly. Remember when I said we just live in a flat spiral disk of our Milky Way galaxy? Well, if we were to line up our Milky Way plane, it would line up just like so, right down the middle. And astronomers still wanted to make sure that there was galaxies through the plane of the Milky Way. So you can see they had a purple survey of galaxies, and you'll notice that there's not as many, and they didn't find as many as far. Pretty much, we have to wait for technology to improve, get better, and once that happens, we'll be able to map out all these areas that haven't been mapped out with galaxies. So you can kind of think of all this stuff, but in every direction if you were to look. But we just got to wait for that technology. So it's just a matter of time. But folks, it looks like we're running close out of time on our 30 minutes of the tour of the universe. 30 minutes is just not enough time to talk about the universe. So let's continue pressing on. And now we're going to be coming across some really far distant objects known as the quasars, which are going to be these orange data points at the very edge of the large scale structure of the universe, so on the right side and on the left side. So those are the quasars, and these are short for quasi-stellar radio sources. And these blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, planets, and stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, folks. So here we are at the very edge of the observable universe. And what we're looking at is something called the cosmic microwave background image, or the CMB image for short. And all evidence indicates that the universe we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And this picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo either. Instead, what we're looking at is a temperature density image, where the light echoes of the Big Bang are color coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny, and they vary no more than 1 part per 100,000. But these small differences eventually gave rise to the large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us. So let's make our return trip back to planet Earth. Let's find a nice entry point through all these quasars and galaxies. This looks like a good spot right here. Oh yeah, right there. And let's make our return trip back to planet Earth, folks. And folks, we are crossing an expanse of 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. And we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes and preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope. And there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we're now entering our Milky Way galaxy and we're heading straight for that radiosphere. And now we're approaching our star system, our solar system, and passing those spacecrafts we sent out in the 1970s to explore our solar system. And we're making our way to the third rock from the sun, our home world, our pale little blue dot, the only place we humans have ever called home. All the people you know and love all live on this one rock in space. And it looks like we're passing the orbit of the moon, the furthest we've ever sent humans out into space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. I want to thank y'all for stopping by and watching it with us today. I hope you did enjoy it. But with that being said, that's the end of our Tour of the Universe. And thanks for stopping by.